Hello, today we're looking at recapping the Macintosh SE and SE30 analog boards. If you don't know what recapping is, it is taking out the fluid-filled electrolytic capacitors and replacing them with new ones. We're going to leave the ceramic capacitors, the film capacitors, everything other than the electrolytics in place because they don't leak or dry out over time. What you're seeing here to my left is an open back SE30. This has its analog board in place, and then of course we have another analog board over here that has been removed. There are 3 revisions, and we're going to take a look at those in detail, and that's why I have my Larry Pina Macintosh Classic and SE Repair and Upgrade Secrets book here that will give us a little bit of guidance in that regard. The Macintosh SE30, for those of you who don't know, came out in January of 1989, and the Macintosh SE came out in March of 1987. So both of those machines are more than 30 years old now of the making of this video in February 2019. And that's long enough to where you would want to, if you're going to purchase one of these machines, or if you already have one, you definitely want to replace your electrolytic capacitors in those machines, even if you don't see any serious problems. Because over time, I guarantee that at least some of those capacitors have leaked their electrolyte out. Some of them have had it partially or completely dried up, which means that your analog board doesn't have the capacitance that it once had, and all manner of problems can result because of that. This video also has one bonus. I'm going to actually, in addition to recapping the analog board, replace the flyback transformer on one of my analog boards because it has a little bit of a problem. Somehow this little bracket ended up getting broken. This is when I received this machine. I purchased it used, and I'm not sure if it happened during transport or just broke over time, but this is broken and it's extremely dirty, and the epoxy is a dark brown color, which kind of indicates that it may have gotten a bit too hot. So this is the flyback transformer and what we're going to replace. The flyback transformer, the new one that I have, is sitting here. I purchased it a number of years ago, but it was purchased brand new, so I'm going to use that as a replacement. I haven't looked recently, but if you look online, perhaps eBay, I'm sure that you can find them. This is part number 1570042-C, which is the newest revision flyback transformer. So let's get started. To begin, let's consider the Larry Pina book I just showed you and consider the 3 board revisions as mentioned here. Revision A, B, and C. The dates, 1986, copyright dates extend to 87, and then on the newest it extends to 1988. And in the actual part number, 820-0206- at the very end will be A or B or C. The actual secondary part number will be the same for all of them. Country of manufacture, Korea or Singapore. You may find that a revision B is made in Korea or Singapore. It could be an earlier one. This is just a basic guide on the board revisions. But as it says down here, it doesn't matter if you have an SE or an SE30. So any of these boards could be in your machine because of the official board swap policy. And here on the next page, it's telling us that the actual revision ID will be in the upper left corner of the board, so you can determine which board revision you have. But basically, the capacitor list that we're going to look at today will apply to any of the board revisions. And here is one of my analog boards. You can see that this is revision C, and this letter is oftentimes written in with a Sharpie pen. So this is very common to see here, 1986, 87, 88. So this particular board we're looking at here is the newest revision. Basically, the primary difference between the board revisions will be the fan. Now, on this particular one, I replaced my stock Alina fan with a Silenx because this is quieter. But on some of the older board revisions, they have what's called the squirrel cage fan. So if you have an older model analog board, your fan will not look like these boxer fans, square. It'll look more cylindrical. And those fans are okay, but they just make a lot of noise. So if you can swap out the fan, that's really best. And also the flyback transformer version could be a version C on some of the earlier boards as well. So just to show you here the film capacitors that will not be replaced, all of the red ones that you see here, we're not going to touch those. We're only going to be touching the electrolytics, which have they're pretty easy to spot, they're not difficult. And again, we'll go through the list so that you know. But by the way, this connector here, I disconnected it. You may find that the connector itself is burned. And if that's the case, you may need to resolder on the back side because there could be a trace broken. This sometimes makes intermittent connections. You can still buy replacement connectors from Mauser and possibly DigiKey as well. I bought my replacement from Mauser. You can buy both the male and the female as replacements. So if you see a burn mark, then you're going to need to do extra work on your analog board in addition to swapping out the capacitors. So here is a Mauser cart containing all of these components amounting to a whopping $12.48, not including shipping, and is linked in the text description underneath this video. Assuming you're watching it on YouTube, you just need to click Show More if you have a desktop computer, or click the little caret next to the text to expand it out. Anyway, the link is in there, and this is what you'll see when you click that link. And I put in this customer number column here the actual component number, capacitor C18. And you can see here it's a 22 microfarad, 50 volt, 20% tolerance, axial capacitor. So yes, I did pay close attention. Some are radial with the legs going straight down, and some are axial with the legs coming out either side. And you can see that some of the components are the same, right? C13 is the same as C24, and that's why I've listed 2 here. And then C2, C7, C22, C25, they are all the same. 100 microfarad, 25 volt capacitors, so I put 4 of them here. And so on. And if you want to learn more details about a particular capacitor, you can just click on the number here, and it'll show you a picture of it. Then it says they've got 904 in stock, and it shows the quantities. You don't get a price break until you order 10 or more, but chances are you're not going to be recapping 10 analog boards. But because this price does not include the shipping, it's usually advantageous if you also recap something else like your Sony power supply. I have a video on that. There's a lot of things you can recap in vintage Mac. So what I'm saying is this is a cart that is only for recapping your analog board, but when you put together your own cart, you might want to consider adding some other components just to make sure that you're getting the most bang for the buck, because shipping will be added to this price. At this point, we should talk a little bit about safety. I've got this partially disassembled, but the information I'm going to show you here briefly should be of importance to you. First of all, if you're working inside these old Macs, even though I'm making this video for you to help you to replace the capacitors, I can't be there with you. I cannot hold your hand. At the end of the day, this is my liability release. You're doing this at your own risk. You need to exercise certain caution. You'll notice that this is not plugged in. The power cord goes over here. It's disconnected. Never work in the back with it connected. You don't want to do that. And then you want to make sure that your CRT is discharged. If it's been off for a few days or a week or even longer, chances are the bleeder resistor will have bled it out and you should be fine. But who knows? The bleeder resistor could be damaged. It's best to discharge your CRT. If you don't have a special tool, I'm sure you have a flathead screwdriver like this and a wire. Alligator clips are preferred, and that's what I have here. I just alligator clipped it on to this flathead screwdriver, and then the other end of this wire is going up here to this bolt. Now normally there's a little circuit board connected to the back here, and there's a one wire that runs up here to this bolt. I have it removed, but basically what you're doing here is you can see that this wire goes from the CRT to the flyback, and then that little wire will run here to the back of the yoke of the CRT, so you're discharging any charge that's in the system by doing this. And what you want to do is you want to don't touch this, don't touch anything here. Definitely don't touch these wires, right? When you're discharging, you can hold the plastic, you don't let your hand slip, but you're going to be touching like this. And if it has a charge, you're going to hear a little pop, or maybe you might see a little pop, just like when you shock yourself when you're getting out of your car. And you would, to actually remove it, you can press on it a bit, and there's these little hooks that are inside, and these hooks are, well, what the charge that it holds it in inside the hole. And that's all there is to discharging. And once you've discharged, then it's a matter of pulling everything out. Now in this, what I'm showing you here, I have the power supply removed. Yours obviously will be connected, but you'll need to take out the analog board. And it's safe to do that because on the back, you've got this insulating sheet, which prevents you from inadvertently shorting out the bottom of the capacitors with your fingers. So to begin, you'll want to remove this little sheet that covers the bottom of the circuit board, the motherboard, and this sheet has an insulating material on the bottom, and that's why if the little feet on the bottom of the motherboard touch this, it's not shorting anything out because it's insulated. So even though it looks like there's a metal sheet at the bottom, yes, it is metal, but it has this very important insulator here. Now, of course, in your machine, you're going to have the power supply, and that's going to have 4 screws here, 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 and here. And you can see mine are removed. And actually, I removed one of my screws over here. There's actually 2 screws that hold in this analog board over here, and 2 here. So you'll remove this little screw down here and its shield. And to remove it, you just pull up and out. Now, it's going to take a little bit more if you have your power supply attached on the other side. You want to be able to unscrew that so you can more easily pull this off. But even then, you're going to have wires that are connected to the other side. And the place where all those wires will be attached are all these connectors you can see here that you're going to have to disconnect before you can actually pull it out. And so that's also why you want to discharge the CRT, because you're going to have to pull off that wire and then disconnect this connector up here. And once you do that, it's free. We can see here that this is the latest revision C board. Yes, there's an F that's actually just not Sharpie pinned, but it looks like it's printed on there. But as we saw in the Larry Pina book, there's A, B, and C. So this is the newest revision. And we can also determine that by looking at the fan. The fan is your standard square boxer type, indicative of the latest C revision board. In order for us to start our desoldering job, we have to remove this white insulating sheet. And to do that, we must remove the little black plastic holders. 1, 2, 3, 4, 5. So what you want to do is get on the component side of the board with a flathead screwdriver, and you're going to need to push like so. And that will allow you to pull this right out. And once you have all 5 removed, it's then a simple matter to pull off this sheet, revealing our work area. You can start with any capacitor you like, but I'm going to start here with one of the more challenging ones. Challenging because it has a fair amount of hot glue. The amount of hot glue on your board will obviously vary because it was clearly applied by hand, so you may have more or less than this. And if you're lucky, it may have already pulled off of this frame, which means it should be easier to pull out the capacitor. But since mine is on there pretty good, we really do need to slice through it with a knife. I would suggest do that rather than stick a a piece of metal or flathead screwdriver in there and pry it out. But since we're going to throw this capacitor away anyway, it really doesn't matter. So it's your choice on how to get the hot glue out. But if I take my X-Acto knife, my box cutter knife, you can cut through. It just takes a little time. And here you see that cut worked fairly well. Note the polarity of this capacitor. The stripe for the negative is on this side. The positive silk screen is not shown because the hot glue is covering it, but the positive is on this side. So when you flip the board over, this is the positive side of the capacitor and this is the negative side of the capacitor. So when you put in the new one, you need to make sure you have the polarity correct. I've had this particular analog board disconnected for a very long time, but in your case, you may not have. So before you desolder any of these capacitors, just confirm there's no charge in them. Take your multimeter ground probe to the ground, plus probe to the plus, and we can see it's 0 volts. So no voltage in these capacitors, and it's safe to desolder it. When desoldering, I prefer to use a copper desoldering wick. Before using that, however, it's good to put a little flux on here. If you don't have flux, well, actually you do have flux if you have solder. The rosin core flux inside, that's the meaning here. Solder, you just put a little fresh solder on both of these pads, and that will give you enough flux to where, and enough solder to where your desoldering wick will better be able to do its job. Now keep in mind you need a fair amount of heat. I'm using 350 degrees Celsius on a desoldering station here. Most good soldering irons should have that, but keep in mind that on this ground pad, it takes a lot of heat because look how big the trace is. I mean, it's a huge amount of trace, so you're heating up that copper there. All right, so now we can put on my desoldering wick, and what you're doing is you're transferring that solder over here to this copper wick. And the harder one will be this one, because we are working against the underlying copper pad, which is quite massive. And the combination of wiggling, pulling, and heating allowed me to get him out. And there he is. Here's some residual hot glue, which you can pull right off, and we can see there's the plus. So that will help guide you in with your new replacement capacitor. We can see that the capacitor we need is C14, and if you use my Mauser cart, you'll be able to have this marked on your bags, just like mine. It'll say C14, so that'll make it easy for you to get the right capacitor out of all the bags that you order as replacements. Now we can compare the new capacitor to the stock one. The new capacitor is rated at 25 volts, which is a good thing, and the old one is rated at 16 volts. Both have the 4700 microfarad rating. So the new one is a little bit shorter than the old, but it's also a little bit fatter. Nevertheless, this one will fit inside the holes. It's a perfect fit, and you can see it doesn't even touch. Even though it's wider, it does not have any problem being in this close proximity to the shield around the flyback transformer. So let's solder him in. I pried the legs, this leg this direction, and this leg in the other direction so he wouldn't fall through, because I've got him upside down now. And we'll apply some solder here. But still, what I'm going to do is I'm going to put my finger on him and push him up while I apply the solder, just to make sure he's not standing up by his legs, that his base is sitting on the PCB. You might want to blow on it before you release him. Make sure it's cooled. And then you can release him and solder in the other side. Make sure you put enough heat on this ground foot because it's a hard one to get on. Okay, and then you can snip off the excess feet. Here he is all soldered in. Now you can decide if you want to put hot glue on it or not. The reason why it was there is because you don't want them to wiggle around. And actually there are little vibrations that go through here. I mean, it's right next to the fan. So to keep it from wiggling on its feet, it's probably a good idea to make sure he's secured and put a dabble. You don't need to put nearly as much as you saw was on here before, but just put a little on there to make sure he's not going to move when touched, which means even when this fan is running, he's not going to vibrate or anything like that. And just to satisfy my curiosity, I'm going to measure the ESR and the capacitance of the stock capacitor that we just removed. I'm going to discharge it, make sure it's discharged first, and then I'm going to apply the leads here on it. It says it's 4.24 millifarads, 0 ohms, which isn't too surprising because the ESR of these capacitors should be very, very low because the capacitance is very, very high. So even though it's rated at 4,700 microfarad, we're getting only about 4,200. So it's a little bit low capacitance. Not extremely low, but just a little bit low. And so now I'm going to measure a replacement capacitor that is from Mauser, because I bought multiple to do multiple boards, and it's a little bit higher. So it too has an ESR of 0, which isn't quite true. It has a little ESR, but it's too low for this meter to register here. And it's saying, even though it's 4,700 microfarads, it's 4,460, which is within its tolerance. So even though we're not seeing any major problems on using this meter, very well the old capacitor could have problems. I didn't see any sign of leaking, but it still could have had some of its electrolyte dried up. Before I proceed, I'd just like to show you that even though the connector on this wasn't burned, this trace is noticeably discolored, and the solder here is cracked. And vibrations plus the pressure on the opposite side of this connector can cause that. So what I'm going to need to do here is apply fresh solder to this part, but it would probably also be a good idea for me to fix this link between this here and here, just to make sure that there's enough current flow that even though this got very, very hot, almost like it was burned, I want to make sure that it's not a high resistance line. So putting another thick piece of wire from here to here is what I intend to do, and most likely you will need to do that too. That's especially true if you have a connector that looks like this. You can see that it's not only the female that's burned, but also the male, noticeably burned and even cracked. So in this particular case, you might even want to replace both of these connectors. So I decided to desolder this one circular pad here. This is where it was getting hot on this trace, so it's noticeably dark. And I didn't see any cracks along this point. Sometimes you'll see that, and if you see any cracks here or it partially severed, you'll need to solder a wire. Also, I used my Fluke 8845A to measure the resistance from here to here across this entire trace, and it's extremely low. I'm getting 1 milliohm, and I know that the resistance of my wire isn't the problem because when I cross the leads, it's like micro ohms. So this is, for this thick trace, it's not surprising that I'm getting just barely 1 milliohm for this trace, and I would say that it's good, and all I needed to do was just apply some fresh solder to this particular point. The next capacitor I'm going to desolder is C15 for two reasons. Because we're going to replace it with a non-electrolytic type. We're going to use a film capacitor. And because there's hot glue here, and probably on yours as well, and I would not recommend using an X-Acto knife, a box cutter, because I don't want you to cut into this coil. So what I'm going to do is desolder him on the bottom, and then I'm going to use a heat gun and loosen up this hot glue so I can pull him out. Putting on fresh solder, as I mentioned before, making it easier to desolder. So here is my heat gun, and I'm going to use that to not burn him up, but just to try to add enough heat to melt this hot glue. And there we go. Here is the old capacitor side by side with the replacement, and the replacement is also 3.9 microfarads. However, it's rated at 450 volts just because I couldn't find one that had less voltage, and it's okay to get a part rated with higher voltage. This is also 5% tolerance, which is better than the original, and we're going to just show you a little ESR measurement comparison right now. Measuring ESR here at 120 Hertz, which is typical for many data sheets. So if you're doing some comparisons, that's a good frequency to test at. 8.6 ohms. And the capacitance, 3.7 microfarad. It's rated at 3.9, so it's within tolerance. This may seem to you like a high ohmic value, but actually, because the capacitance is fairly low, it's only 35 volts, this is typical. It's not out of range or anything for capacitance or ESR. Now let's test the new one. We see that it's spot on, 3.90 microfarads, and it's, of course, in reality not 0.000 infinity ohms. There's always some ohmic resistance in there, but it's less than 100 milliohms. It's probably 10 milliohms or so, so it's not showing up here. And that means we have slightly better capacitance and much lower ESR. All said, a good replacement capacitor. And in order to make the legs fit, I needed to bend them a little bit. So one of the legs will be bent under the body, and I put a little bit of heat shrink tubing. It's not necessary, but I just did it for good measure. And those two legs will fit right in here. This is how he will fit in. So he fits in diagonally right in between this component, and this connector. And even though he's just barely touching that connector, if we put in the male counterpart, we see it's not a problem because the hook is right here, and it's not going to pose any problem to have the film capacitor to be in that location. And here's another angle for you. and another angle. We'll now solder him in. Here he is, all soldered in. We can see there's just a little bit of movement if we push on him. So I'm going to put some hot glue on, and while my heater is hot glue gun is warming up, I'm just going to say that this is steel wool. It's used for cleaning off metal pieces, especially legs of components. If you've got some tape or gooey gunk on them, even if something is a little bit rusted, you can use this because it's made of steel to easily clean them off. And so what I did is I stuffed some of this inside this hole here because there was a little bit of black corrosion on it due to the intermittent connection there. And I cleaned that up and blew it out. So that way I don't really need to replace this connector. The plastic is old, I suppose. Replacing it with a good one, there's nothing wrong with that if you have a spare, but as I showed you before, there was nothing wrong with the trace at bottom. It just needed new solder, and I cleaned up this, so the contact should be okay so long as the female matching connector of this is cleaned up as well. And there was a little bit of hot glue on this coil here, but it had unstuck itself from the board, so I'm going to apply new hot glue to this component as well. And by the way, you might have asked, why didn't I talk about plus and minus polarity on this? And the reason why is because the capacitor that was in there was non-polarized. And these film capacitors also do not have polarity, so it doesn't matter if you reverse it, it's fine. But you have to be careful on all the other capacitors because, like this one over here, you can see it's negative stripe. All of the other capacitors are polarized. So if you mess up on those, you're going to have an explosive situation on your hands. But for C15, you don't have to worry about it. So long as you get a film capacitor or a non-polarized replacement that's similar to the one that was already in there, then you'll be fine however you insert it. And I'm going to put some hot glue around this connector because I believe that's going to secure it better. Any vibrations in the board are going to make it, with this hot glue here, less likely that the connector is going to vibrate loose and crack some solder below. And the great thing about hot glue is if you want to take it off, assuming you don't put too much on, it's possible to still do that. And my hot glue job over here is done. Now, so far, we've replaced this capacitor C14 and this bipolar, non-polarized capacitor C15. I'm not going to show you the replacement of all of them so as not to make this video too long, and honestly, I really don't have to, but just to show you another type of capacitor, which is very easy, by the way. It's the axial with the leads coming out the side. I will change one of these for you so you can see how that's done. But again, it's very easy. And the other ones I will do without you seeing them, and I'll just show you the final board when I'm done. But basically, you've got some hot glue on the side. You've got some needle nose pliers. You'll need to carefully pull that up. You could use a heat gun on it, but honestly, for these, they're pretty easy to pull up, so it gets kind of messy with the heat gun. It actually melts it more, so you might want to just pull it up with your finger or some little tweezers to get it off the board. The axial capacitor that I'm going to show you how to replace is C18, which looks like this. Again, this is a polarized capacitor. You can see the negative strip here on the right side of it. 22 microfarad, 50 volts, plus minus 20% tolerance. And here's C18 here. We've already desoldered him, so it's just a simple matter of pulling him out. And we can see it's a simple matter of getting the polarity right, because there's a little plus here on this side, which means the negative side of our replacement needs to go over here. And when C18 is soldered in, he looks like this. Again, note that the negative stripe is on this side, positive on this side. And here is the fully recapped board. You can see that I've applied some hot glue to various capacitors. That's because, especially on these three capacitors here, and this one also, the feet are not perfectly matched to the holes, which means the spacing is a little bit more narrow on these capacitors. The holes in the circuit board are a little bit wider, so the bottom of the capacitor doesn't sit flush with the circuit board. It stands up a little bit, and in that case you should put hot glue on there just to make sure that it's not going to vibrate around on its legs, which is important because this fan really, it doesn't really vibrate it in a noticeable way, but it does add constant vibration as long as this fan is running. And then of course you have hard drives and other things in your machine too that vibrate through the chassis into this board, and you don't want this to be vibrating on the legs, because if you do that, chances are that could open up a gap to where some of that fluid electrolyte could leak out. So putting a little bit of hot glue on that, and of course on the other components so that they don't flop around, is important. I put hot glue on this one as well. I also desoldered the flyback. I'll take him out here so you can see there's one capacitor in here, and I put a little bit of hot glue to secure him. So this one too has hot glue, and this one. So even though this one sits flush, I still put just a little dab on him along with this one. And of course you saw how I put the hot glue on this connector to ensure that it's going to be less likely that one of the solder joints on the back will be broken due to vibrations over time. Here's another view of the recapped board. You can see, especially on C9, the white outline is significantly bigger than the replacement capacitor. Don't worry too much about that. This is the right value. Newer technology results in smaller capacitors. But the reason I wanted to show you this, and this capacitor here is because all of them can actually be physically larger. And if you do buy higher voltage versions of these capacitors, higher than what I used, then you might get one sufficiently large enough to where the feet would better match the board, and the bottom of the capacitor could be flush with the board. It's not absolutely necessary, but you have the physical room that you could go with a higher voltage capacitor, and that does have benefits too. It may lower the ESR a little bit, and it's not going to hurt anything at all. That's what I can say. So the capacitors, if you want to use my list exactly, you're not going to go wrong. You're going to have what you see here on this board. But if you want to go higher voltage, don't obviously go 10 times higher. If you get the capacitor too big, it may stick out so much that it's going to bump into something. But a little bit bigger than what you see here is not going to be a problem, or even for this one, because the stock capacitor was quite a bit taller and fatter than this one. Now, before I solder in the replacement flyback, I just wanted to show you the bottom of the old one. This bar here connects this nut to this nut, which is of course goes up and around, and is this little piece that was broken, which is really the main reason I'm replacing this. But I will remove these nuts and just show you. You can see this is all grounded. This solders to the circuit board, and that's the circuit board ground. So this silver shaped piece connects to this brass shaped piece, and normally this is one piece that comes all the way around, and here this goes down through the body of the flyback, and then of course comes through this. So it's pretty much a 360 through the body itself. And even though this was grounded around this L part here and going up to the top, it was broken at this point here. So it's obviously not a good situation there. It seems, I don't know if it really serves an electrical purpose as much as a stability purpose, but I do believe it probably does serve an electrical purpose, because if it was just stability, then they would not have built this particular part around it, which looks like it contains some type of material that allows the flyback to work properly. Anyway, I just wanted to show you the pieces that were broken, and now I'm going to put in the new flyback. One small problem here. I put the flyback on the reverse side of the board just to show you the problem. The ground pin is just ever so slightly not aligned to the factory hole here, and you can see that the other pins are all in their holes. So bending this to make it fit would require like a 30-degree bend, and I would prefer not to do that, so I'm going to drill a new hole right under him so he will better fit. And that won't be a problem because this is a huge solder pad. And here it is with the hole drilled out. You can see the stock hole is the one here on the left, and then the hole that the pin is coming through on the right is the one I just drilled out. I used a 1.5 millimeter small drill bit, that's the smallest I had, to start the hole, and then I used a 2.5 millimeter to complete the hole, which is just about as big as the stock hole, and you can see it fits nicely through, as do all of the other pins. And now it's a matter of cleaning off the flux. You can see I've got an old toothbrush here, and I've got my dehydrated ethanol, you can use rubbing alcohol, in a spray bottle just to make it more convenient. So I can spray some alcohol directly on the board this way, then take my toothbrush and clean off this flux on all of the solder joints that I soldered. And again, you can see this one looks burned, but we did the resistance test and determined that this trace going from here to here is in fact still low resistance, and it's fine. If you have something similar or something worse or any doubts, you can, there's a couple ways to do it. You can put a wire from here to here, or you can very, very carefully with an X-Acto knife scrape off this green on this PCB trace, and then that way solder will stick to it, and you can just put a clump of solder between those two solder joints. So many of these boards have that problem, so that's why I mention it. And here's the board after I cleaned off all of the flux. Now with the flux removed, our replacement flyback transformer in there, all of the capacitors replaced, and hot glue properly applied, we can proceed to testing. I'd just like to say that some of you may also wish to change out the fan. The stock Elena fan is a bit loud, and you can make it quieter by swapping out with another fan like this. This is a Silenx brand. It's a 60mm fan, and it, to my hand, moves a bit less air. I mean, the data sheet says it moves just as much air, but to my hand, it just doesn't feel like it moves as much air as the stock fan, but pretty close. And I've been using this fan in another analog board, which I haven't recapped, and it's been working fine for a while. So if you have another preferred brand, you can try that, of course. I just used the Silenx, and you don't have to change the fan. I just wanted to mention that it might make your experience a bit quieter overall, especially if you replace the internal spinning platter hard drive for an SD card solution. And here we have our kit ready to be reassembled. This is the power supply I recently recapped, which is a Sony power supply, so you can see the video on the recapping of this. And of course we have our recapped analog board, and this is the little CRT yoke board here. So let's get started reassembling. First thing we'll do is, we can see that this CRT board goes here. Just slides right on. And then we need to put this wire back up here. It's now time to put in the power supply, but I'd just like to stop and say, you just recapped something. You triple checked, or at least you should have, all of your capacitors to make sure the polarity is correct. Nevertheless, we haven't done the smoke test yet, so make sure that your logic board has the minimum amount of RAM you need. You don't have any upgrades on the board itself. There are some zero insertion socketed type accelerators. Make sure you don't have one of those. Just have your basic motherboard, and of course nothing in the PDS card slot, because should you have made some kind of grave error, you don't want a voltage spike to zap anything truly important. But again, to make sure that doesn't happen, you definitely want to make sure you use good capacitors and make sure the polarity is correct. Okay, so with that in mind, we will put our power supply here. And this board, by the way, I had put on the back cover here. Remember, we had removed all of those little plastic holders. They're very easy to put in. You might need to push it a little bit with your fingernail and then push down on it, but it's not difficult. And then we put in this board like so. Now we have to put in this part here into the socket, so you might need to move your power supply around a little bit to accomplish that. You will also want to start plugging in your connectors. Your power supply connector going over here to the far left, if this is left, it's far left. Then this connector coming off the CRT will connect here, up at the top. Then you have a little connector here coming from the yoke board. And then we have here for the motherboard. I disconnected the yoke board just so you can see the motherboard connector a little bit easier right here. I'm going to plug that in now. And you can also see just below the yoke board connector, there's this connector down here, and that is for the hard drive. We're not going to connect a hard drive right now, so we'll leave that disconnected. And so just to repeat, we've got the connector from the CRT here, then over here at the far left, we've got the power supply. We've got our power coming out. So the power supply is coming into the analog board from this connector and out of the analog board through this connector to the motherboard. And then we've got our little yoke board here. And by the way, on the yoke board, you can see these capacitors. These are ceramic capacitors. There's no capacitors on it that are fluid-filled electrolytics that need to be replaced. So this is fine, even though it's many, many decades old. And so now I'll just close it up and we can proceed to the next step. The key to screwing the analog board in correctly is, first of all, before you put in any screws, make sure that it's properly inserted. You can see there's these little plastic slits here. Needs to fit into them here and up here. Also, there's these metal hooks that go under the board. Needs to be fitted into there. If any of these places are not fitted correctly, do not screw it in. And then you have your screws for the power supply, which will secure the power supply to the analog board. Alright, so those 4 screws have the power supply in there. And then we have some screws over here. So if you screw in the power supply first, then you can still shift around your analog board to get these lined up. I should mention that if you want to ensure your analog board is secured in there correctly, you should put your finger under here and feel the screen brightness. And if you can't move it, or if it's very difficult to move, then you could have something misaligned and you need to fix that. And don't forget your little shield here. And now we want to get our ground screwed in. This is the chassis ground. It connects our power supply to the chassis ground here. And next is the motherboard connector and the power cable from the analog board. Snapped right in. And finally, we want to connect our flyback cup here to the CRT. And there's 2 prongs that will fit into this hole. So you may need a flat head screwdriver. And now for the smoke test. I've got my power cord plugged in and I'm going to flip the switch. 1, 2, 3. Good sign. We've got the chime. I don't have the keyboard. I don't have the mouse plugged in. Just a bare bones system. And the screen was dimmed. The screen was dimmed. But here it is. So we get a screen here. And we've got the flashing disc icon. Okay, it looks like the screen needs to be shifted a little bit to the left, but I can show you how to do little adjustments like that now. But this is the moment of truth. This is showing that our recap job was successful. All the wires were connected correctly. So this is great. Now to adjust the screen, moving it up, down, left and right, you have 2 tabs back here. By the way, my machine is turned on, so you need to be careful here. You don't want to touch this, okay? It's turned on right now. You can hear the fan, it's spinning, and you really need to do it with the machine on in order to see your adjustments. So what I do is I use these plastic tools. This little tool has a plus and minus driver, which is important for other adjustments that are made on the opposite side of the analog board. And you can even use a toothbrush. It's an insulator, right? And I'm going to use this side of the toothbrush. And you might have to hold one, like here's the tab over here. that will adjust left and right, and then this tab here adjusts up and down. So if you want the screen to go up, you push it up, and if you want the screen to go down, you push this one down. But keep in mind that this one might rotate the other one, so you need to securely hold the other one while you push up and down on this one, or whatever adjustments that you need to make. But if you slip and you put your hand on here, you're going to have a serious problem. So I mean, if you want to play it super safe, I suppose you could turn it off, make an adjustment, turn it on, check, turn it off, make an adjustment, turn it on, check, but you're going to have to do that a lot of times. It's really best if you're just very, very careful. You know, don't put your hand on this. It's insulated. You'll be okay, but just, you know, avoid it and get your plastic insulated tools. If you don't have one of these, just get another toothbrush and you just manipulate this tab and this tab depending on if you want the screen to go up and down or if you want it to go more, be more centered left and right. Now, if you need focus or brightness or other things, those are on the back side of the analog board. We will now take a look at the 4 adjustments on the analog board. As you can see, the computer is on. Definitely you want to have your plastic tool here. Don't put anything metal in these 4 places. You've got 1, 2, 3, 4. At the far left is the focus. To the right of that is the cutoff for brightness. Down here we have the height of the screen, and then we have the width here. So let's take a look at the cutoff. Right now I have maximum brightness adjusted with a little thumb wheel down at the bottom left in the front of the computer. So can we make this even brighter? So I put in my minus side of the driver, and if I turn it counterclockwise, it gets brighter. But you can see that that's a bit too bright. So if I turn it clockwise, it gets dimmer and dimmer and dimmer. But as I said, I have the knob at the bottom left front of the computer turned to the maximum. So we want to get the maximum brightness, but without showing any white in the black portions of the screen. So you see, this is a bit too white because I'm seeing some white in the black bars of the screen. So I'm going to turn it down until the black bars just barely go black. Okay? And then that's perfect. And then we can take the front wheel and you can see it will dim. Alright, so that's our brightness. Now the focus is a bit trickier because when you adjust focus here, when the icon in the center or the very center of the screen is perfectly focused, you'll notice that the rim or the edges of the screen become out of focus. So it's a balancing act. You're not quite going to get this perfectly in focus or the edges perfectly in focus, but at least you'll get them the same focus. And I wish you could get everything tack sharp, but this is not an LCD, so oh well. Anyway, that's this here. Now if we adjust the height, that's down here, and you can see the screen. It's getting shorter and shorter, and now it's getting taller and taller. And you might say, well, what should I do? You want to have the top and bottom black bars thicker than the left and right. And of course you want your disk to look like a floppy disk, so if it's too tall or too wide, you know that based upon what a floppy disk looks like. And the same here as well. If you turn this, it's a more subtle adjustment here, but you can see the bars on the left and right are getting more narrow now. So the height and width adjustments are based upon what you perceive to be square. So if you boot into a graphics program, draw a perfect square with a shift key held down, that's really the best way to do it. And that's your 4 adjustments here on the side. Here's the last tip I'll leave you with. If you find that your screen needs to be rotated left or right, the entire screen needs to be rotated just a little bit, you'll need to shut off your computer, disconnect the power cord, discharge your CRT, and then you're going to need a tool to, a plus screwdriver actually, to partly unscrew this and what you want to do is, for the sake of safety, just get some rubber gloves. That's the best thing to do. Some people say to use one hand and put the other one behind your back, and that's because you don't want, if you get shocked, you don't want electricity going through your heart. But if you're wearing 2 rubber gloves, then you'll be okay. But what you're going to need to do is unscrew this screw so that you can grab these little spokes here, and you're going to have to twist this yoke collar with all these wires. So you're going to be twisting this collar around the CRT yoke in order to get your screen lined up right. Chances are you're not going to need to do that. So if you don't, then don't even mess with it. But if you do need to, and I'm not saying one side of your screen being messed up, but the entire screen, turning it, say 10 degrees to the right or 10 degrees to the left, that's what you're going to have to do. Unscrew this and then rotate this. Now, if you find that your screen, not the entire screen needs to be rotated, but there's portions of your screen that are problematic, in other words, distortion, one edge is a little bit too high, something like that, you can see here there are magnets, the little pink ones here, and they go around. You can see there's under the yoke. Back over there, there's another one. They're going all the way around. There's 8 of them. Okay. These little magnets most likely do not need to be touched, but if you're getting one edge of your screen that's distorted, what you're going to have to do is twist them either clockwise or counterclockwise, and that will remedy the distortion. But keep in mind that if you twist one of them, you're going to have to twist another, because it's never just one of them that's going to fix whatever problem you're having. You're going to have to twist other ones to make sure that whatever adjustment you made doesn't adversely affect the other corners. So it's really fiddly if you touch them, and they're sealed with a little bit of glue. So once you're done, if you do decide to touch them, you should put a little hot glue on them, or some other glue, just to make sure they're not going to be vibrated out of place again. You definitely do not want to be touching these with your bare hands until you've discharged the CRT. And even then, you might want to put on some rubber gloves and then only deal with one of them at a time. Don't touch these while it's on, because you can see the copper wires here. You don't want to shock yourself here. Okay, you need to take great caution when manipulating these. You can touch these. These are insulated, but I'm just saying there's a lot of electricity going through here. You don't want to have it turned on and be manipulating these. Even with rubber gloves, you're going to be maybe accidentally touching that. So, with insulated gloves, you'll probably be fine. But you need to exercise great caution, because this is where the high voltage is. Most likely you won't need to touch these though, and don't even think about it until after you've made all of the other adjustments you've seen in this video first. And this would be a very, very last resort. Well, that was an exciting hour, wasn't it? At least for some of you who actually did watch it for the full hour. I've been watching the Google Analytics on my other 1 hour long videos, and it seems that the average view duration is only 8 minutes. Now, I will admit that those numbers are probably skewed by millennials who come by looking for 3 minutes of entertainment and finding out they've actually come across a video that allows them to do something useful. So those type of viewers will skew the view times a bit. But for those of you who did watch this entire video, or who are considering it, I applaud you, because you're well on your way to recapping your analog board. If you have an existing vintage Macintosh SE or SE30, or considering one. Some of you may not even own even a single vintage Mac computer yet, and for you this information is extremely useful because it shows you what's involved, what to expect. You might be buying one off Craigslist or off of eBay, and maybe it's untested, Or maybe it is tested, but not by somebody who really knows what they're doing. Chances are, if the capacitors haven't been recapped, you're going to have to do it. And even if the seller says it's recapped, most likely they're talking about the motherboard. They're not, I would seriously doubt they're talking about a fully recapped system, which would include the motherboard and the analog board and the power supply as well. So I have videos now which cover the power supply, which cover the analog board. I don't yet have the main logic board recapping video. I'll have to do one of those one day. The problem is that all my boards are recapped, so it's not so easy for me to do that. But if I can get around to it, I can do that too. But the most important parts, which are largely overlooked by many vintage Mac owners, are, well, what you've seen in this video, which is the analog board, and of course the power supply too. Now, this video, if you haven't watched all of it yet, why should you watch an hour? First of all, none of us have time. I don't have time. I don't do YouTube for a living. In fact, I've never made a single penny. Not a penny, and I kid you not. I don't make a single dime off of YouTube because, number one, I don't have 1,000 subscribers. You need to have 1,000 subscribers to make money off YouTube. Number two, I don't allow ads. Even if you have 1,000 subscribers and if you don't allow ads, then you're not going to monetize, as they call it, make any money. But the other reason is that I don't really see myself as being a hobbyist making a lot of money off YouTube, so I don't make money off YouTube. I don't have Patreon. I don't even advertise a PayPal account. If someone wants to donate a machine to me to do a video on, I might accept that, sure. But I don't appeal to anyone for money. And so this is really a labor of love. I do it because I make time to do it. So to watch my video, what you're watching now, in its entirety, or any of my other SE30 videos, which are also about an hour long, you really have to make time to do it. On a holiday, set aside the time where you're not going to be bugged. And yes, as a family man with kids, you can do it. You should spend time with your family. Yes, I agree. Don't ignore your family in order to enjoy your hobby all the time, but there's sometimes you need some time for yourself. And if you don't have a soldering iron, you're going to have to buy one, and you'll see what's involved here. I put in more information in the text description below. But yes, you have to make time, and if you cannot or are unwilling to make time to watch this entire video, then I question if you have the patience and determination required in order to do this recapping job. If you've done the recapping job before, then you largely don't even need my video, so you could skim through it maybe to refresh yourselves on a few things. But I don't talk about what I had for breakfast. I don't talk off topic, so when you watch my videos from start to finish, you're going to get on topic, good information. And the information that I don't cover can be covered in books like I showed you at the beginning, this Larry Pina book, which covers the Mac Classic and the SE, which includes the SE30. I'll put a link to that down below, but it is the Repair and Upgrade Secrets book. You can find it on Amazon. It's out of print. You can also find it on eBay, but you can find used copies. And even if they say it's a new copy, it's been on the shelf for years, chances are it's used and abused a little bit. That's not so important. But having a book like that in your arsenal is useful, because you might have a situation where you recap your analog board, you have a recapped motherboard, and you have a recapped power supply, but you still have a problem. You need those reference materials to dig a little bit deeper. And if you want to go beyond the book and beyond my videos, there are great information resources on the internet, one of them being the 68K MLA forum. It's had its problems through the years. I've been on it for years. I'm JDW there as well. They've had hard drive crashes. They've lost a lot of data. I could go on, but I won't say anything more. It's still a great information resource. And the great thing is they've got a good search feature. So if you register and become a member of that forum, again, look to the description below for a link. That can help you out a lot with other people who are even more well-versed in the intricacies of these machines than I am, who are there and are very enthusiastic about getting machines repaired and helping others. Also, I'm a member of a Facebook group. Yes, even on Facebook you can get help. The Vintage Apple Macintosh Enthusiasts group has about 5,000 members there. The benefit of that is less obtrusive moderation. It's not a free-for-all, but they're pretty easygoing there. So if you tend to say things that most moderators don't like to hear, then you might have an easier time there. I'm also a member of that group there. And again, having books to supplement the videos like I've made, getting online, this is important because there are always gotchas. There are always special cases. And you might have one of those even after you've recapped everything. Now, for those of you who are new to YouTube, or maybe you're a veteran YouTube user but you don't know what a text description is, under the video you're watching right now, you'll see if you're looking on a desktop computer, then on the left side, underneath the video, you'll see my name, JDW, when it was published, and under that, you'll see a couple, 3 lines of the text description. And just beneath that, you will see in all caps, show more. Click that, boom, it drops down, and you'll be able to see all of the links. And believe me, I spend a lot of time on the links and information I put in the text description, just like I do in my video here. And you will also find a link to the Mauser capacitor list, which will contain all of the capacitors you need to do what you've just seen in this video. Now, I will say, you can, I don't get any kickbacks for that. I don't get any money back for that. It's not a referral link. It's just a link to a cart. And you can buy that, but if you only buy those capacitors, one of each, you're not going to have enough in your cart to qualify for free shipping. And if you're a first timer, and if you're worried you might fry a capacitor, you could get 2 of each, especially if you have more than one computer you need to recap. Also, if you watch my other videos and you want to recap not only your analog board, but your Sony power supply, assuming you have a Sony, you might want to add all of that together in a single order, and that way the total amount of your order would be big enough to where you would probably qualify for free shipping. So give that some thought before you fire off your order. Anyway, I just explained to you the text description on a desktop computer. If you're on a smartphone or tablet, Google makes it a little bit more frustrating. There's no show more. There's a little down arrow type of caret mark you've got to tap on to see that text, but you can still do it on a mobile device. So if you're watching me on a tablet right now or a smartphone, you can still see that text description. And I would encourage you to do that because there's a lot of information in there that you will find useful. Well, the other thing I can mention is that there are some people who come by and find these videos, and maybe they were looking on how to cook a turkey and they got frustrated. Oh, this is about vintage Macs. Well, I'm frustrated, so I'm going to click the thumbs down. Well, you can combat those crazies by clicking the thumbs up. I don't get anything for that, but I do watch the thumbs up, and the thumbs up tell me that maybe I've done a good job, and some of you actually are out there watching the video and you wanted to give me feedback, so I appreciate that. Also, in the comment section, please feel free to leave a comment. I'm not one of those famous YouTubers who make a video and then abandon it. You know who they are. If you're into tech and you watch all the major tech videos, you know who they are. They're so famous, so big, so busy that they put up their video, and then there's the free-for-all in the comments, but they hardly ever even click like on people who comment, much less reply. But I do, and I try my best to reply to every single comment, so I'm more than happy to engage you in the comment section. But I would say, if you want to talk about something totally unrelated to this video, then it might be best if you join that 68K MLA forum and or join the Vintage Apple Macintosh Enthusiasts group on Facebook, so that you can engage with people more than just myself, and you might find that people there are even more responsive than me. If you wish to donate something to me, I don't really want to appeal too much for that, just because I do this out of a labor of love. Okay, I don't make money, and so I can't guarantee I'm going to make it a video immediately, but you might also consider that I'm in Japan, and so there would be shipping issues and other things that go around with that. But I am open to that. The Larry Pina book that I just showed you for example, covers the Macintosh Classic as well. Now, I don't have a Macintosh Classic, so that's why I haven't done a video on that yet. But I do believe that the Macintosh Classic is the most beautiful of the compact vintage Macintoshes with the 9-inch display. I really love the look of it, even more than the SE30. However, the SE30 is the ultimate compact Mac because of its speed and expandability. The Classic and Classic 2 can't touch it in that regard. But I just want to say, if you have a Classic or are going to buy one and never opened it up before and looked, you will find that it's a totally different analog board, power supply. So the video you just watched now that covers analog boards recapping for the SE and Macintosh SE30 does not apply to the Classic. The book I'm recommending does cover various details about that, but not this video. So that would be another video, assuming I ever get a Macintosh Classic to review that. But anyway, I appreciate all of you who took the time to watch at least some of this video, and I hope that it's a useful information resource for you that can help you get your Mac up and running. Before I go, I just want to plug it one more time. I can't be responsible if you shock yourself, so you need to be careful. I mean, if you're recapping something, triple check before you plug anything in. Discharge the CRT. All of that is covered in this video, but be very careful because there are high voltages even after you've turned off the machine. So I don't want any of you to get hurt because you watched one of my videos. But at the same time, I don't want to scare you and frighten you and make you think it's something so impossible that no one except for an electrical engineer can do. I do have an electrical engineering degree. That doesn't mean I know everything. It just means that I know how to be cautious, and I know how to tell you how to be cautious. And it is possible for you, even if you don't have a soldering iron. If you follow my video, I think you really can do it. You just have to be alert. Don't do drugs, don't drink, stay alert, don't have lots of noises around. Have a desk kind of like mine where you've got all the tools ready and right there to go. And you'll be able to get your machine up and running in pretty fast order. It might take you a few hours if you do it really slow and aren't sure what to do. But once you have your vintage Mac up and running smoothly, it's just the greatest feeling. Now, I've been a Mac lover since 1984, so for me there's a lot of nostalgia there. And for some of you who are much younger than me, you may not have the nostalgia, but you might have the interest in just having fun. And you can have fun. It's a different kind of fun than with emulators. It's real enjoyment when you get an actual machine here that's up and running. In some of the old games, I don't think they're just useful for old games. You can actually do word processing on these machines. They can be fairly useful. I mean, some of these machines cost thousands of dollars, like this SE30, thousands of dollars. And yes, that was a long time ago, but there still is. I mean, I can even connect this to the internet today. So have a lot of fun. Be safe. Thanks for watching. I hope this helps you. Bye-bye.